So recently we started learning about CUDA, which is a programming language that NVIDIA created that allows you to program NVIDIA GPUs very easily. This is a language that looks a lot like C and C++. The nice thing about CUDA is that you can create various different applications with it. It's most commonly known for its use case in AI applications. So if you're training or running inference on LLMs, you may have written some CUDA kernels to get that up and running. The use case that I personally find more interesting is computer graphics. So in this video, I kind of want to go over how would you create a CUDA kernel to create a checkerboard like this and write code that almost looks like it's a GLSL shader. By the way, all the other code about, setting up the code on the CPU and the GPU, setting up the block size and the grid size, running the function, and then waiting for the GPU to finish, copying the result from the GPU to the CPU, and then writing that to this image, and then freeing the output. So all that code, by the way, is the same as before. The only code that's different is this right here, and this is what I want to go over in this video, which is how do you create a simple checkerboard kernel that allows you to create an image like this. The first thing that you need to know when you're creating a simple CUDA function like this is you're going to need to tell NVCC, which is NVIDIA's CUDA compiler, that this function is going to run on the GPU. When you create a program, you need to be able to call code from the CPU and then send that to the GPU, right? There's two types of code. Some code is only going to run on the GPU. That's what you might use the directive, I believe, __ device for. And if you want to create a function that is called directly from int main, so I've got int main here, and I'm calling this function directly from int main, then of course you're going to want to label it as global, because this hints to the NVCC compiler that this is a function that is running from the CPU and it's going to go to the GPU. Of course, the first thing that we're going to calculate is the XY coordinates, and this is going to come back to the block ID and the block dimension as well as the thread ID. I did do a little bit of a review on GBT, which is grid block thread, where thread is kind of like the lowest level. So if you're not familiar with exactly how that is related, you're going to have to watch the previous video. But anyway, point is, we've got an image here, and I've defined this image to be 400 by 400, and I'm creating the block size to be 16 by 16. So what that means is that the CUDA kernel inside of here is going to use those values when it's calculating the block ID, the block dimension, and the thread ID. So here we've got an image that is going from 0 to 400 on X and 0 to 400 on Y. We know that the size of the block is 16, right? And we know the size of this is 400 on the X and 400 on the Y. Since I simplified the process and just done 16 and 16 on each, I think it would be easier to just kind of look at it from the X perspective, right? If we wanted to calculate the current X and Y coordinates on this image that we're trying to render to, block ID, which can be between the values of 0 and 25, because 400 divided by 16 means that you can kind of split this image up into 25 different blocks, right? So the block ID is going to be between 0 and 24. The block dimensions is going to be 16. And then the thread ID can go between 0 and 16, where we specified that the block is 16 by 16. So inside of each block, the thread can go from 0 to, 15. So this is how we calculate the specific XY coordinate on this entire texture. Basically, when you're sending stuff to the GPU, there might be cases where you might actually be running more threads than necessary. And essentially what that means is that if your X or Y is greater than the width and the height of the image, then you don't need to run that operation, right? You could just return early. Now that we've got the basics out of the way, we can actually start with the checkerboard. So here we've got a checker size. So checker size as 100. So what that means is that I'm essentially trying to construct, a checkerboard where each of these blocks is a 100 by 100. And this is just calculating, think of it like the checker ID. So let's think about it, right? X can be between 0 and 400. X is the pixel coordinate on the X plane and Y is the pixel coordinate on the Y plane. Both of these can be between 0 and 400. And what happens when you do X divided by 100? Well, you have to remember that this is an int and there's going to be integer division. So if X is 0, it's going to be 0. If X is 1, it's going to be 0. If X is 2, it's going to be 0, all the way up through 99 on the X axis. But then from 100 to 200, you'll get 1. Because 100 divided by 100 is 1. 101 divided by 100, when you do integer division, is once again 1, so on and so forth. That's going to give us, think of it like the ID of the box. And this if condition is a simple way to determine which box is supposed to be colored which. So we know that the values of checker X can be between 0 and 3. Checker Y can also be between 0 and 3. So what happens when we add 0, 0 modulo 2? 0, 0 modulo 2 means that it's going to be 0. Essentially the first block, we're going to set that to red. Now what happens if checker X is 1 and checker Y is 0? So that's this block right here. You get 1 modulo 2, which is 1, which means it's not going to be red, but it's going to be white. So you get this white right here. What happens if you have checker X is equal to 2 and checker Y is equal to 0? That's this block right here. 2 modulo 2 is 0, so once again we get the red square, and so on and so forth. So just for example's sake, we could do 1, 1, right? If we get 1 for X, checker X, and 1 for checker Y, we're in this coordinate right here, and so that's 2 modulo 2 is 0, so once again we'll be red. So that's essentially what we're doing here. We're constructing these RGB values based on this simple function, and this is kind of where, for me, personally the fun part is when you're using code that looks kind of like GLSR shaders to construct this image. And of course, the last thing that we're going to want to do is to convert the XY into the output. Now, one thing to note is that the output is a single dimensional array. Basically, what we're converting is XY kind of representing the two-dimensional image, but we need to calculate it as if this entire image is one-dimensional, because the output that we've got here is a unsigned character array. And so that's what we're doing here. We're just essentially calculating the pixel index, and then of course we're passing in the RGB values. So that is how this works. And yeah, that's all I really want to talk about in this video, which is just how you create a simple little checkerboard kernel in CUDA. If you've made it this far, hit the like button and consider subscribing for more random C++, CUDA, GPU programming deep dives. Thanks for watching, and I'll catch you guys next time.